So in this way, let me remind you, so the whole purpose, you've got most of it, the purpose, the meaning of the antiderivative. So think about back in the days of calculus, calculus 1 that you were learning, right? And you got a function level, some f of x, right? And then after finding the derivative, back in calc 1, right, finding the derivative, we use this symbol. Am I correct? Right. So now think of it the other way. So that also means from this understanding from our calc 1 right here, we can imply another understanding that. So now f of x, I'm using all lowercase now, right? But f of x now is the antiderivative. Am I correct? Okay. The antiderivative of a prime. You want to say no? Right. Or as a matter of fact, using the word b right here is not quite correct. So the f function right here from originally is one among the antiderivatives, right? Of that f prime. Are you following what I'm trying to say so far? Okay. And so now we take advantage of this understanding. And then so another thing to remind you, you guys learned from your calculus 1. This is now. If we're taking the f prime to be at the function, some function level, right? Because f prime itself is, from what calculus 1 understanding, f prime itself is another function, right? And then we can take another function, another derivative here, and we're coming up with f double prime, right, from our previous understanding. You guys with me on that? Okay? So right from that relationship now at calc 2 that we're learning, then yes, you can also see that, hey, any f prime, right, has that relationship. F prime is right, that is an antiderivative, right? Antiderivative, right? Of f double prime. See that relationship now? Right. So I mentioned this for a reason. Let's now look at another example. Hey, from last time, let's say we call this example 3. Right? So what I have here, about that prime of x, right? Given as 2 to the fifth plus 6x squared. Right? And then further, so that's one piece of information. And further, we have given condition that, hey, f of 2 equals negative 2. Right? Our goal here is to find f of x. Right? So let's get in, shall we? So here's this example right here that we're about to do. This problem we're about to do takes directly, applies directly to the information we have mentioned up here. So what we're given here is some derivative, right, or the derivative of some function, and we don't have the function. We have the function right now unknown. That's why we want to find that. So, well, say enough, but starting with a derivative. So how do we find that the function itself? That's where we're going to do antiderivative, right? According to this understanding. You guys follow me on that? Okay? And so yes, the first line here is the first start here is simply to find f of x, right? We need to, well, from our antiderivative, right? We're gonna, from our derivative given, we're gonna take the antiderivative, right? We're gonna anti-differentiate it, okay? And so that means that we're gonna take the antiderivative on that specific function, 2x to the fifth plus 6x squared, right? If we take the antiderivative, come back. You guys feel that still? Okay. And so now the work comes easy for us. This here, now at this point we can see all the rules we've learned previously applies. We got this, and this derivative currently got two terms, right? So taking the antiderivative, we take antiderivative term by term. So the first one, and I can start going a little faster with the pace right here. I can start going a little loose with all of those the minor details. The 2x to the fifth, making it 1/3, right? X to the 6th power. You guys agree? Right. And then the next one right here, making it 2x cubed, right? Okay. And don't forget we have a plus c. So that's the antiderivative level right there. That's why the logic here, the philosophy, the fundamental I was saying earlier, the function originally is only an antiderivative, right? We have found a general family description like that, right? The general description of the entire family of antiderivatives. But so now the idea is, we thought we found the answer, but which function? Because right now it's a whole family. Right? And you can say that, hey, f of x can equal to any of these, but they may differ by the constant c. So we want to find out, hey, which one is the function f of x specifically meets this requirement. So when x equals 2, right, we come out with the output -2. So in that way right here, I'm going to substitute it in. This means x equals 2, right? So f of 2, according to this general derivative, general antiderivative, we're looking at 1/3, right, times 2 to the 6th power degree, right, plus then 2 times 2 to the 3rd power, right, plus c, right, and then we're ending up with some expression. On the other hand, it was given, right, initially here, that's when x equals 2, the output comes out being 2. Then you feel that. Okay. So now with the two information here, we have our right to equate that. So now we're looking at, so 2 to the 6 is making it the 64, so it's 64. I wrote 63 for some reason. Okay, and you guys need to start getting your calculators ready to help you with some later math problem here. So 64 over 3, right? Plus, that's making it right, 16 plus c. That's the first part here, but we are equating it with -2. You guys following? Okay. But then from here, from this equation that we have just now produced, right, we are now ready to solve and find that final. The goal here is that with that specific c value right here, then it satisfies that the function here at 2 equals -2. Right? So go ahead and find that particular c value for me right now. We find that by simply subtract all of these terms to the other side, right? Yes?
Negative 118 over 3.
Negative 118. 18, okay, over 3. Anybody else confirm with that? Right. Yep. And so that means what? Once we've found that c, then we can write our actual function, the actual function, because right now it's not that particular one. This is just a whole family of antiderivatives, right? But the actual one that meets this requirement here is going to be just that. So what did I find for my antiderivative? 1/3, right? X to the 6 plus 2x cubed, right? And then with that c now we have found here, it's minus 118. Over 3. So this is the one that, hey, it's the function having this derivative, and that function itself satisfies this requirement. Okay. So this is where we have found our final answer right there. Okay. But now, before I move away from this example over here, let me give some even better insight of this problem here to see, so that you can see the impact here for this kind of problem. It's not like one problem I brought up to make you guys doing the math for fun here. I mean, yes, you get more opportunity to practice on your antiderivative skills, right? But let me tell you that. See, this here from the earlier days, I've been calling this the general derivative, right? So I got general derivative. And we found a general derivative. And this one right here now, in the way how it was, see, it's one solution, it's one answer. The answer, more generally, we call it as a solution, right? It's one solution that particularly solves this problem right here, solves this given condition. See what I'm saying? So this requirement right here, you will see this kind of problem right here a lot when you go to your differential equation later on. So right now I'm giving that to you sort of like a preview kind of problem. Okay? But when you arrive at the differential equation, people call this the initial condition. Okay? You're starting out with some derivative and you want to find the actual function. That's your goal right there. And that function here has to meet this given initial condition. That's the way how to call it. And a lot of times people in the world, differential equation call it as the IC of your problem. Yeah. Okay? And so this one here particularly solves that initial condition here, right? It solves by going from derivative to the function and then meeting with that the initial condition. So this function here, particularly with the C that we found, it's called a particular solution. Okay, you guys see how it's named like that? And then the whole problem actually, hey, you have a derivative given and we want to find a function. Like I said, right now it's a preview problem for you guys. There'll be more opportunity for you to practice on taking antiderivative. But there is a whole class, sort of like a 300 level math course at the university. They call this problem right here, okay, the whole problem from beginning to the end. I mean, from the beginning to stating what that ultimate goal is. It's called an initial value problem. Okay. It's a one famous term for that, an initial value problem. Even the differential equation people call it as the IVP. Right? This problem right here is called an IVP, initial value problem. So when you go outside of the classroom here, you talk to anyone and you mention the IVP, they'll understand what you mean. Okay. So let me bring in another problem along that line right here. So this next example here is, because we have time, so I'll just bring it in. It's sort of like an extension to that IVP problem right there, that IVP over there. So we are putting it as let's find some function h of x, right? If we know that h double prime 48x squared plus 18x minus 4. And another given condition right here. H of minus 2 equals negative 69, and h prime of negative 2 equals negative 51. Okay, so let's get into it. So yes, same goal again. We want to find that final function h of x, right? But what's given here for us is an h double prime. We got a second derivative given. Okay. So back on that chart, I was saying, back on this little reminder right here. So yes, the second derivative is the derivative, first derivative, but then the derivative here. So we have all of these relationships. Right? The derivative, the function itself is an antiderivative of the f prime, right? And then the f prime is an antiderivative of the f double prime. So now think about it, sort of like the planning. We're backtracking this criteria, right? This scenario over here. So we're having an f double prime, but we need to find the f of x way up here, right? So we need to backtrack it a little bit. So we got to find the f prime first, right? By taking an antiderivative. And from the f prime right here, we take the antiderivative one more time, right? To arrive at that final the function we get. That's the goal. That's the plan of the problem we get. Okay? So let's go ahead and backtracking it. But along the way that of our work then backtracking, produce other details. That's why I'm going to be bringing in these information. So we need to find h prime. So let's go taking the antiderivative of the 48 x squared plus 18x minus 4. So that's one function. We're taking the antiderivative. You guys all with me on that? Yeah? Right? And then of course we got three terms, right? And then with coefficients and with constant terms all over again. Once again, it's another opportunity to apply our understanding here. So now I can pick up the page like the earlier example that we've done. So first term here, after taking the antiderivative, it gives me a 16x cubed. Does everybody agree? Okay. The middle term right here, well, we connected with the first term by addition, right? And then so now here I'm looking at the 9x squared. We look at that still, right? Minus 4x, right? But don't forget, we always have to do. See that the c is what's handing us after here. How about you? I'm at the first level, so let's call it C1 here. Right, I'm at the first level. So what I found here is a general antiderivative for the h double prime, but that's so basically what I have here is just the derivative of our tentatively h of x right here. Right? But we got hung up with that C1 right there. And so that's why now we need to utilize this condition rate that's given right here. So the requirements here say, hey, we want that h prime so that when h prime of x equals -2, it has to equal negative 51. So now we can take that information. Okay. H prime at -2 or h prime of -2. According to this, well, the math that we have found right here, it's going to be 16 right, times -2 cubed plus 9 times -2 all squared, right? Minus 4 times -2 and plus C1. While you can see that on the other hand, h prime at -2, right, of -2 here equals -51 as the given. Okay. That was the given piece of information. So now in that way right here, I am allowed it to, in that way I can go ahead and equate, right? So have you gotten the sum of all of these? There's the 16 times the -2 all cubed plus 9 times -2 all squared, all of that. Plus the C1, what did you have for that combined terms right here? So you're looking at what I'm talking about before we solve for C, right? So -84 plus C1 equals -51. Right, we can equate all those two. So now, once again, that was because combining these terms here gives -84. So C1 can be solved by just simply adding the 84 over, right? So 84 minus 51 right there, right? So we're looking at C1 right here, right? 33. So we found for this problem right here that h prime is particularly required, right? To be, or concluded to be 16x cubed, right, plus 9x squared minus 4x, right, plus 33. You guys doing that still? So that's a particular solution for this h prime, but that's not our ultimate goal, right? So we need to go one more step right here. So now h of x, right? We're ready for that final step. H of x is found by simply taking the antiderivative on that previously found h prime. So we're looking at 16. The antiderivative of 16x cubed plus 9x squared, right, minus 4x plus 33. Okay. Let's take that antiderivative. Right. Any questions for me so far? So the work here is once again similar to the earlier work. The first term gives me as an antiderivative. Right, it's going to be a 4x to the fourth. Right. Plus, and the next term here is going to give me a 3x cubed. The next term here gives me a 2x squared. Right? The last term here as a constant term gives me a 33x. But don't forget we have to plus a C2. Okay? Sort of like the C2 is another constant at that step 2 we now work, right? At that level 2 of finding antiderivative. Right? So now we're going to utilize, so once again, what we have arrived here is simply just a general antiderivative, right? And we haven't found that particular one that meets this requirement yet, right? So we got to really get onto that. So now the h at -2, right, equals all of these here. We're substituting in with -2, so 4 times -2 to the 4th power. Plus 3 times -2 cubed minus 2 times -2 squared, right? Plus a 33 times -2 plus a C2. That's on one hand right here. And then h of -2 on the other hand is given as that requirement right here equals -69, right? Okay, so once again, I need you guys to help me out with adding these terms, including the powers right there before the C2, right? Combine all of those like terms first. All right, anyone got some answer for me? for this line right here, what do you have after combining all of these terms together? Yes.
-34.
Okay, so that leads to, you said negative 34?
Yeah.
Right, so negative 34 plus the C2, right? And we want to equate that with the negative 69 right here. Right? They are supposedly the same, the equal value, right? And then from there we can solve for the C2 value. So in this case right here, I'm going to add 34 to both sides, making it C2 equals, right? 34 minus 69 right here, right? So that leads to, I'm running out of space right here. C2 has to equal negative 35, right? So I'm going to write my final answer. Okay, so this little corner right here. Right, so now I'm ready. My final particular function, h of x, right, that meets the two requirements here. Right? That is 4x to the fourth, right, plus 3x cubed minus 2x squared plus 33x, right, and we found minus 35. We have found that. Right? That's how things work out.